Whew, let's get this done. Test 3 key. So now we're looking at polynomials. You need to graph it. But you must note the x-intercepts, the y-intercepts, multiplicity, and the end behavior. Let's do it. In order, here are the x-intercepts. I write down that the x-intercept is where y equals 0. So I take all my y and set it equal to 0. Well, guess what? This is only equal to 0 if one of them is equal to 0. So either this factor is equal to 0, which would give me 0. This factor is equal to 0, where if I take the fourth root of both sides, I get this. And then if I solve for x, I get 2/3. And then the last one, this crap cubed, might be equal to 0. If I take the cubed root, I get this, which means x must have been -2. Well, notice what happens. Those are my zeros. Good job. Same thing as my x-intercepts. My y-intercept just means that x is equal to 0. Well, guess what? I already found it. But if you plug in 0 here, you'll get 0. And then it wants to know the multiplicity. Well, for this 0, its multiplicity, I just go back and look at the associated factor, which was x squared. And since it is raised to the second, as a second power, the multiplicity is 2. And that just means we touch there. That's my local behavior. For the 0 of 2/3, I look back at the power that the associated factor of 3x minus 2 was raised to. Since it was raised to the fourth, the multiplicity of that 0 is 4. Since it's even, that means the graph wants to touch there. Then for the 0 of -2, I look at the power of the associated factor of x plus 2. And since its power is 3, that means it wants to act like an odd function, so it crosses at that 0. That's its local behavior. Okay. Well, the end behavior, I look at the leading term. So if I were to multiply all this out, which would be ugly, I would get one term plus a bunch of other stuff. Well, that leading term tells me what the end behavior is. So for the end behavior, for x is large, my function really is equal to that leading term. So this is going to give me a -x squared as part of my leading term. Then if I were to multiply this sucker out, the 3x to the fourth is going to be in my leading term. And then if I multiply this sucker out, an x to the third is going to be part of my leading term, if you imagine what that would look like when we multiplied it out. So then I multiply all these together and I get -81x to the 9th is going to be what my leading term looks like for this polynomial. Since it's an odd degree and a negative leading coefficient, that's just trying to tell you that the end behavior is going to be up, down. Okay. So, and what does it mean to be up, down? It means as x goes to -infinity, y goes to infinity. As x goes to +infinity, y goes to -infinity. Put all that together, and that's what your graph should look like. Just make sure that it's nice and smooth, right? Okay. All right. For the following exercise, can you write a polynomial of least degree for this picture? Well, the first thing I do is pick out the zeros. And so at x equals 3, the associated factor would be x minus 3. And since it touches there, that means when I go to write the polynomial, it's going to be x minus 3 squared. Let's see. When I go to x is equal to -2, the associated factor is going to be x plus 2. But since it crosses, that means the associated factor is going to be odd, so I'm going to put a 1 to be least degree. For the 0 of -4, we go through it. So for the 0 of -4, the factor is going to be x plus 4. Since we go through it, it crosses, so the multiplicity is going to be odd, so I use a 1. When you multiply all that together, I get a polynomial that looks like this. Now, if this is all you had, then we wouldn't worry about this point. But since we know this point, I must incorporate that information. So it turns out that there must be some constant times this stuff that's going to help me to incorporate this information. So when you plug in 0 into our function, you better get out 3 is what this point is telling you. So when you plug in 0, you get out 3. Then the only thing left to solve for is k. When you solve, you get k is equal to 1/24th, and that is your polynomial. Okay, perform the indicated operation and simplify. Main thing to know here is that I squared is equal to -1. When you multiply this stuff out on top, you get this. But then how do you divide? Oh, don't forget, I squared is -1. So this is actually 4 plus 9, which is 13. So now I have this thing. And how do you divide complex numbers? In other words, 13 divided by this thing, you multiply by the conjugate, which is the same terms, but a different middle sign. Here we multiply by the conjugate of the denominator, because that's what we want to get rid of. So when you do that, it ends up giving you this. But then you know that A plus B over C is just equal to A over C plus B over C. So you end up getting this over C plus that over C. Yeah. All right. Then I to the 23rd. Well, since we know that I squared is equal to -1, I need to get this in terms of I squared. So first thing I can do is pull off a singular I. So it's I to the 22nd times I. But then I squared raised to the 11th is the same as I to the 22nd. But I squared is the same as -1. But -1 times itself an odd number of times is -1. -1 times I is -I. Okay. For the following exercises, solve the equation. To solve this, I can use the quadratic formula if I just felt like it, or just subtract -77 and take the square root. So when you take the square root, just to be clear, you're going to get plus or minus the square root of -77, but that's the same thing as what? Plus or minus the square root of -1 times the square root of 77, but the square root of -1 is just I, so your answer ends up being this, just to show all the gory detail. Here I have this. Well, to solve it, we know that a main way to solve equations by hand, a really great tool, is to what? Is to set equal to 0 and solve, and set equal to 0 and factor. That's the main way to solve things by hand in algebra and pre-calculus. Yeah. So it's not the only way, but it's definitely a way that you should consider trying first. So if I distribute this and then subtract 20, I end up getting this quadratic set equal to 0. So first, you distribute, just to be clear, and so you end up getting x squared minus 4x is equal to 20. And then you subtract the 20, and you get 0 is equal to x squared minus 4x minus 20 equals 0. Right? So I've got this. So now it's a quadratic set equal to 0. You either factor, or since I can't factor, I punch the quadratic formula. You do a bunch of stuff and get down to here, right? Well, then you say, what's the largest square that's inside of 96? If you need to do a factor tree, you can. But since it's 16 times 6, the square root of 16 is 4, so that pops on the outside and leaves a 6 on the inside. Well, then if you have stuff plus stuff over 2, you can put the first thing over 2, and the second one over 2, so that's why your answer turns out to be this. Okay. Over here, this is one we did in class. It is a pretty famous equation whose solutions are what's called the golden ratio, 1 plus the square root of 5 over 2. So just practicing using the quadratic formula. Here, classic question of an applied problem with a quadratic. I mean, just have to be able to do these. So when does something reach a maximum height? That would be at its vertex. You must know that the vertex is negative b over 2a. So that's when does it happen, so the x value. And then what is its maximum height? It's wanting to know the associated y value. So you plug in the input of 3 that we found here and get 256 feet. Well, then when will it hit the ground or the ocean? That's where the height is equal to 0. So you take the entire quadratic set equal to 0, and you get 7 or -1, but 7 is the only one that makes sense in context. Look at 9. So if you're doing this sort of division, when you're doing this sort of division, make sure you have the placeholders. So we add in placeholders because I don't have a cube or a square or a to the first, a linear term. Then you just divide. You say, look, I have 2 terms here. They get attacked by 2 terms. So 2 terms here want to attack 2 terms. And we're thinking x times what gives me x to the 4th. So that when I multiply, they can cancel out and give me 0. So it turns out that x cubed times x gives me x to the 4th. And then x cubed times -4 gives me -4x cubed. And then very importantly, you're now subtracting all of this. So x to the 4th minus an x to the 4th gives me 0. And no x cubes minus a -4x cubes is a plus 4x cubes. I bring down a term, and then now I'm saying, hey, what times x will give me 4x cubed? And the answer is 4x squared times this x will give me 4x cubed. And then 4x squared times -4 gives me -16x squared. When you subtract, you get -16x squared, or positive, excuse me. Follow it all the way down to the rest of it, and you get 255. Okay. With a remainder, remainder of 255. All right. So consider a polynomial. What is the number of zeros? Number of zeros is always going to equal to the degree counting complex and repeated roots. The max number of turning points is going to be 1 less than the number of zeros. How might you fail to see a 0? If there are either complex roots or if you have a multiplicity greater than 1. So number of zeros, if polynomial has degree 77 is 77. Max number of turning points is 76. For this one, let's see. It says find all the zeros. Well, guess what? It has 4 real roots. 4 total roots, including complex, excuse me. So real and non-real. I know there's going to be 4 total roots. So to find a starting place, I do the factors of last divided by the factors of first. So I get this. So you just try one of these. So I try this over this, which is 1. And yes, when I plug it into here, I do get 0. So it is a solution. It is a 0, a root. So if x equals 1 is a root, then x minus 1 is a factor. So to find the other roots, I take my polynomial and divide by x minus 1. That will pull out that root, and what comes out has the other 3 roots in it. So when I divide this by this, just like we did before, I end up getting this polynomial. So now the other 3 zeros are in here. So now I need to solve a new problem, this equal to 0. So remember, this is my list of possible zeros for my question, so maybe I go and I try 2. Well, lucky for me, if you try 2, you get 0. That means that x minus 2 is a factor. So I can pull another 0 out of this by taking x minus 2 and divide that into my cubic, and I get this quadratic. So I've now pulled out 2 zeros, and the other 2 must live in here. Well, thank goodness for me. I now have a new problem of setting that equal to 0. You factor and get the other 2 zeros, and here are our 4. Right? And that's it. Have a wonderful time studying. You are going to do great. Just make sure when you study, it's not just looking at things. Make sure you're actually doing the thing and practicing. Try a problem similar to these that you've never done before and see if you can do it. Have a great day.